Hello and welcome to the structural modeling part of the V20 BIM training. In this part we will see how you create a steel structure hull and how you use the BIM toolset to get there. We will use the profiles panel from which we will import profiles. We will use propagate to propagate details around our drawing. You will see just how powerful propagate is in combination with the details panel, where you can store details and where details can be parameterized so that they adapt themselves towards the new steel structure. In this part, we will start by opening BricsCAD. You will be probably familiar with our workspace. We now need the BIM workspace. So I will open the BIM workspace, and then you can open a new drawing in a millimeter template. So choose BIM millimeter and choose new drawing. So then you will see this interface. You are probably familiar with it. Remember, if you don't like the dark UI, you can always change it by right-clicking somewhere and changing to the white UI, but I will record this in dark UI because I'm quite a fan of it. So what we will start off with is we will start off with a grid. So launch your no selection quad, so by right-clicking on empty space, and go to the model tab. There you can find the rectangular grid and choose the grid to get started. You will see that it's asking me to enter a first point. Down here at the bottom, you see enter first point. I will choose 0, 0 to this, so I just type in 0, 0 and it will start at 0, 0. Then if I scroll out a bit, you see that as I move my cursor, the grid is attached to the cursor, and I'm able to dynamically adjust my grid. You can start off by defining the dynamic dimensions of the grid cells itself, and then going to the overall dimensions. For this, we need just 5,000 on 5,000 grid cells, so we leave it as it is. And then we go to 20,000, the width, and the length on 35,000. So if I press tab, I can switch to the next dimension, dynamic dimension, and and you see the preview of the already put in values. If I now press enter, it will accept those defaults. And then you will see a grid is created, which is automatically numbered from 1 to 5 and from A till H. If you would like to change this grid, a small reminder, you can use block edit. Bedit is the command for that. So choose your grid and type in bedit. You will be taken into the create or edit block definition dialog, where you can choose your grid and choose OK. And then you see your grid as it is. You can move grid lines by just using the move command or the manipulator. You can copy grid lines that's the easiest way to add new grid lines. And you can see then in the properties tab, you don't see the numbers here, but in the properties tab the numbers are there anyway. So down here you see the BIM type is the grid axis and the number is B. That's because we copied the B element. If I stand on the second one, it's also B. So now I have grid lines A, B, B, C, D, and so on. I don't want that. I want to renumber them. So how do you do that? You can use the number command. Just type in number. Select entities to number. Those are the axes along the Y direction. And then you can say which number style you want. So type in N for number style. And then I want letters. So I type in the third option. And then it will now it won't sort them automatically in the Y direction. You have to sort the entities again by using entity sorting. So type in E and just type in along the Y direction that you want to sort them. and then press enter again, and then it's asking you provide the first index. So I provide 1 because this corresponds with A. So I just type in this, and if I now check my numbers, you see number A, and then number B, number C, number D. And if I would now save the drawing, my grid would look like this. I don't want that now, so I will undo my changes and go back to the grid as we had it previously. You can save the drawing so that you don't lose your drawing. So I will save it as Steel Hall. You can also save through going through the BricsCAD icon and going to save or save as, or just type in Ctrl S like I did. And remember, if you get lost along the way, there are also intermediate files. I will show you the intermediate files. If I go to training, intermediate files, structural modeling, and then you will see structural 3, 4, 5.1. The name of the drawing corresponds to the step at which you can use this drawing. So structural 3, it's the one that is ready for step 3. And so you can follow easily along. So that's the first thing we want to do, is create the grid. But because we want to model further onto the grid and we want to use propagate onto the grid, we also need a base slab to have this grid attached to a real 3D object. So I choose box from the create tab, and I draw a rectangle as a base, and then if I go into perspective mode, you will see that I'm dragging it downwards. So I'm moving my cursor downwards with 500. That's what I type in as a value. And then you see that I have a slab with a grid on top of it. So I will just give my grid a color so that you can better see it. So this is now a grid with underneath the grid a slab. So that's the first step that you need to do, is making this grid. The next step is that what we will do is to apply a profile from the profile library. So you can go to structural steel domain. You can filter on the top of the profiles panel. You can filter to structural steel. If you would not see the profiles panel, you can always right click on empty space, go to panels, and then BIM profiles and make sure it's checked on. And then it will appear as an I shape in your stackable panels. So you can now filter using going through the domains, structural steel, and the standard. We will use the Euro standard for the entire duration of this exercise. Of course, you could also do it with other standards, but for this scope, we will focus on the Euro standard. Then you can search for HEA. You already see them here, but if you would be confused which ones to use, it's the HEA. So drag and drop the Euro HEA 300 profile in empty space. And if you now zoom into your cursor, you will see that a profile is attached to it. So this means you can start drawing a profile. I will just escape for a moment because you need to put a setting on, namely the eSnap setting should be on. The eSnap setting, you can right click on it and you can put intersection on, so if a box is around it, it's on. Also endpoint and midpoint you can put on already because we will need them further on in this exercise. So make sure eSnap is toggled on. You see it when it's highlighted, and you can also put ortho mode on to draw orthogonally in your drawing. So drag and drop Euro HEA 300 in your drawing again, and zoom to the intersection of grid line 1 and A. And you see that now it says that it's found the intersection. So I click on the intersection, and then you see, because of ortho mode is on, you can draw orthogonally in all directions according to your current to your current user coordinate system, which is currently the world coordinate system because we haven't edited anything. So you see that now my profile is, the flanges are aligned with the A axis, and I want them to be aligned with the 1 axis. So to change that, I type in Q for quarter turn, and then you see my profile changes by quarter turn. So draw orthogonally upwards and type in 5000 for the height, press tab to see a preview, press enter to accept. And then you see that you can still model further, but we don't want that now. We just want this one column. So just press enter again or escape, and then you will exit the command. What I now want to do is I want to propagate this profile over to all of the grid intersections. I will do that using the propagate command. But first we will take a look at the column itself and see that this, because we dragged and dropped it from the profile library, it will automatically be classified as a column because it's standing upwards. And it will be automatically having a profile, Euro HEA 300, and you will see some other BIM properties that you could assign if you would like to. But now we will just propagate this column over to all the locations in the grid. For that, we will use the propagate tool. So launch propagate from the top under the classify tab. And then it's asking us to select base solids. And the base solid here is the thing propagate will look at to find a similar location. And we want it to be the grid intersection lines, just as the one it is standing on. But actually the column is not standing on only the grid, it's also standing on the slab. And the slab has a grid attached to it. So the slab here is the base solid because we want to propagate it to other locations on this slab, which are defined by the grid. But the grid is not a base solid because it's not a solid, the slab is. And then the detail object is of course the column itself. So select the column. Remember that you have to press down Control if you have your face detection toggled on. For now, I want to have everything off, so I don't want display sides and ends, I don't want to edge prioritization or the face prioritization. I just want to select the whole solids, so that's how I can easily select the sub-detail just without holding down Control, because my selection is set to select entire solids. And then I can press enter, and it will ask me if this is what I want to propagate. So it's asking me to propagate as a block or as a copy. You can propagate as a block if you would like to have the detail object always the same, and if you don't want to model further onto the detail. But now I want to model further onto this column, so I want to copy it as a copy and not as propagate it as a copy and not as a block. So I type in C and press enter. And you see it detects the grid and it applies a profile onto all the grids, but I want to explode it into all different options that are available. So I click on grid and then I click on explode. And then it's exploding in all possible suggestions. So you can toggle off the mid suggestions because we don't need them. Just make a selection box over the checkmark icons and toggle them all off by clicking once on them. Hide those that you toggled off by pressing enter once, and accept those that you still have left by clicking enter again. And then you see this is what we wanted. It is the columns for the steel hull and we will now model further with the first two in the row. So I will isolate those. So in the quad, go to the Select tab and go to Isolate Entities. And then you will see those entities which are isolated. Then I want to draw a line, so I type in line, or I go to the Annotate tab and go to the line command. And then I start from the inside of the beam. Remember that your display sides and ends is off, and also that your display axis is also off. So if you go to the Structural tab, you make sure that in the View tab everything is toggled off and nothing is toggled on, because otherwise if you display axis you can only snap to the axis endpoint, and if you display sides and ends you will snap to the sides and ends. And we want to snap to the real geometry of the column, so we just want only nothing selected as snap, except for the midpoint, which we toggled on previously by going to eSnap and toggling midpoint on. So again, go to the Annotate tab, choose line, go from the inside of the column, so the one facing the other column, and snap to the midpoint, so the midpoint of the flange to the inside of the other column. And if your ortho mode is still on, you will be only able to draw in the orthogonal directions. That's convenient now, because we only want to snap to here, to the other midpoint, which is orthogonal. So snap to the other midpoint that's inside of the column. And then if I show you in non-perspective mode, so right click on the look from icon and choose perspective off, you see that I drew a line that connects the insides of the columns. So I will put perspective back on, and we will now move this line a bit downwards. So if you have nothing selected, so press escape if you have something selected, and you now long click the line, so click a little bit longer than usual, and then the manipulator will show up. We already used that in previous exercises, and now we will use it again quite often to mirror things, to move things. So now we can choose the down axis, so the one pointing up, and we move our line 400 downwards. So type in 400 in the input field, and then you see it's 400 down. Now I want to make a truss from this line, so you could model everything by drawing directly when you drag and drop a profile into your model space, but what we will do now is we will draw lines, and from these lines we will convert the lines into profiles and then make a truss out of this. So I will now construct a truss from this. To do that, I will draw a few more lines. So I hit the line command again, I snap to the midpoint of the line I drew previously, and now I draw upwards with 1400. So again, your ortho mode can be on. And then you see you can model further still. I will put ortho mode off now because I need to go to the midpoint of the inside of the flange again. And then I press enter, and I see that I have the shape of the truss that I already would want to, and in between those two lines I will weave a pattern making the truss of my structure. So now you have the big beams of your structure, but not the little members that make up the truss diagonals. So what will I do now is I will divide the lines that the upper and the lower line into small points, into points that denote a specific division of this line. So I will divide it into an amount of segments, the line, and on each endpoint of this segment a point will appear. So the line will not be literally divided into smaller lines, no, it will be just where the division points are, points will appear. So what I do for that is I stand on the line and I go to the Draw tab of my quad and select Divide. Make sure you don't select Measure because this icon looks similar, but select the Divide command and click it, and then it's asking me to enter a number of segments. Again, if you can see it here in the bottom of my screen that the command line is asking me to insert a number of segments. So I want 10 segments, and then I click enter. You don't see anything happen yet, you would think, but if I make a selection box over this, you see that it has created some points. But how can you display these points easily? Well, that's a setting. So if you go to settings by typing in settings, and you go to PD mode, that's the point display mode, then you can uncollapse it, and you can choose, instead of 0, which represents a point, you can choose 3, which represents a cross. And if the point display size is on 0, it will automatically adapt to your zoom level, the display, the preview of the points. So now it will preview as a cross with a dynamic point size. So you can close the settings, and as you can see, we now can visualize the points, and whether I scroll in or out, they always display as the same amount of pixels on my screen. So that's convenient to see what we're doing. Again, we want to divide the lower line in an amount of segments as well. Because this is twice as long, I will divide it in twice as many segments, namely into 20. So now the divide command should be the first one to pop up at your quad. So select it and now type in 20 for the amount of segments. And then you can see it's nicely divisioned in as many segments for both the upper and the lower line, and we will now weave a pattern in between that. For that, your endpoint selections should be on, your eSnap should be on, and your node eSnap should be on, which I haven't mentioned probably just yet, is that this node eSnap should be on, because then you can snap towards the points. So with me it was already on, and now I can launch the line command again. And I can start to draw from the end point of the line, go upwards to the first node, go downwards to skip one of the nodes, and then weave a pattern in between those. Just like this, so that you actually created a truss. I can show you again if I go to the front view and put perspective back off. You will see that now I created a truss, which is good. This is what I wanted. So this is now a truss, but it's only half of a truss. So we will need to mirror the first half to create a whole truss. But first I will delete the points because I don't need them anymore. So select the points in the structure browser. Just go to the structure browser and uncollapse entities and delete the points just by hitting the delete button on your keyboard. And then I can start mirroring the lines. So select the lines you want to mirror, and then from the quad display in the modify tab, you display the manipulator, and then it will show up somewhere in the middle probably. We want to reposition it. How do you do that? You can click the white grip. So this white grip, you can click it, and then you can move where the manipulator is standing. And I want to move it to this midpoint, and it shouldn't be rotated because if you snap to another line that's a diagonal, for example, then it will rotate itself. So it will, because your dynamic UCS is on, it will rotate itself to the dynamic user coordinate system, which it detects from the entity. So you just want to position it in the middle here, and then we want to mirror. How do you do that? You have these blue lines, these blue arrows, and these are the ones that you need for mirroring. So I select the one in the X direction. And then you see I'm mirroring this entity. If I don't do anything, it will just mirror it and it won't make a copy or anything. So to make a copy, type in C and press enter. And then it says copy mode multiple copies, which is what we want. And then you can enter a distance of 0 because it just needs to be mirrored along the position where we positioned our manipulator before. So press 0 and then press enter again and escape to exit the command. And then you have this truss like you would want to. I see that I haven't snapped appropriately to the endpoints. So I will adjust that so that it's snapped towards the endpoints as we want it. So you see that even after you modeled, you can still adjust your lines to what you need, because now that it was mirrored, I saw that these two lines did not converge in one point. So now I adjusted that. You would probably already have it correctly. If I now delete this middle line, you will see the truss as we want it. So you can save your steel hull and we will work further with this. So like I said, we will do everything in the Euro category. How can you now convert a line into a profile? Well, it's pretty simple. You just drag and drop the profile instead of on empty space. You drag and drop it onto the line. So if you now search for IPE, the 240 we want for the lower line. So just drag and drop onto the lower line. And then you see it applies if the quarter turn is good. So if it's positioned nicely with its flange like it is on the screen right now, then just hit enter to accept it. And you see that the line has now a profile attached to it as well. You could drag and drop each time for every line, but that's a tedious job. So you can also select multiple lines and choose now IPE 200 for the upper lines and just drag onto your selection. And then you see both elements will display a profile, and just click enter to accept if the rotation is correct again. Then you can select all the truss lines, actually, the small braces. You can do that with a selection window or from the structure browser if you would like that, but I think it's easier from the model space. And then you can drag and drop IPN onto this, the IPN 100. And just drag it onto your selection, and you see that it's applied to all of them. Click OK to accept, and your first profile is completed. Save your file again so that you don't lose your changes. And we will now, you see that while we were applying profiles, the Bricscat did a suggestion of what type of elements these are. And if you select the horizontal one, this will be a beam. If you select the diagonal ones, this will be classified as a member. So also, if you select the upper ones, these are classified as member, but I think they are more beams because they are the large structures in my drawing. So I will classify them as a beam. So under the BIM tab in your quad, choose classify as beam. And then it will be classified as a beam. And now we will also be able to use this in our propagation, because in our propagation we will have a detail for this connection, and this will be based onto a beam and two members. So that's why it's important to now classify your top beams as beams instead of as members, so that the propagation later on in this process will work, because Propagate will look to the classification of entities to see whether or not a detail fits or doesn't fit. So now we have everything classified and made as we want. The only thing that is left is to delete the lines that are still there, because the lines were not deleted, so you could use them further, but we don't need them anymore, so you can delete those as well. And again, save your file to make sure you save your progress. What we will now do is we will propagate the truss onto all our columns. So to do that, we have to show everything again. So if you show everything again, you see that we have a whole bunch of columns where no truss is in between just yet. So how do I use propagate to propagate this truss entity over to all the columns? Well, I kind of already said it. I propagate with as base solids the columns, because these define the location where the details should be propagated at. As details, I now choose my truss, because this is not present on the destination location just yet, but we want it to be present there. So I click enter. And then again, it's asking me if I want to propagate as a block or as a copy. I again want as a copy, so I type in C because I still want to model further on it. And then it will create my suggestions. Of course, I will also find the bottom ones, because propagate does not recognize that the bottom is different than the top, because in essence, these two connections are the same. So what I do is I make a selection box over the lower check marks. I click them to make them a cross. I enter to delete the crosses. I enter again to accept what is left now as check marks. And then you can see that these are all propagated along just like I wanted, which is nice. So you see just how easy it is to propagate one detail into a various type of locations. It does ask a little bit of training to see what propagate should want as base solids and as detail solids, but we will use propagate further on in this training, so you will get used to it. What we will now do is we will add some sidebars. For that, go to the profiles panel again and hide the slab and the grid. Just select them, and in the select tab choose hide, because it will make it a little bit easier to model. So I will model a sidebar between the first two columns and then propagate it again into our entire drawing. So I want to go to the Euro tab, but now I want a UPN. And it's not an I shape, so I won't find it in the I shape category, it's in the U shape category. So there I want to find the UPN 120. And I drag it into empty model space so that we can start modeling, start drawing in my drawing again. Where do I want to position the first point? Well, the midpoint of the outer flange of the first column. And there you snap to the midpoint. And then you snap to the midpoint of the second column as well in the Y direction. So snap to that one. And make sure that you shouldn't have snapped if your orientation was not as mine. So make sure it's oriented like this, and use a quarter turn if necessary. Then I don't want to draw any further, so I press escape. And you see that now the sidebar is crossing my column. I don't want that, so I select my sidebar and I go to the structural /MEP tab, and I choose under the modify tab, I choose add eccentricity, and then I choose the outer arrow, and then you see that the solid will shift as opposed to its axis. So the extrusion path will shift as opposed to the axis, and then you can click enter. And now it's positioned correctly, just at the side of my flanges instead of crossing my flanges. I now want to long click the sidebar and move it up with 1500. Because this is the manipulator we want to use to move the sidebar up. And then you don't need to escape the manipulator. You can use the manipulator again to copy multiple copies on top of each other, a bit like an array, but then in separate objects instead of as one array. So what you can do is you can press the up bar again, and then you can type in R for repeat, and then it says copy mode repeated copies. If I now type in 900, it will always take a distance of 900 in between the copies. So as I move my cursor upwards, you will see that the bars are attached to my cursor. So this is pretty convenient. It's a bit similar to an array, but then it will make separate entities instead of one. And you want to make sure that you have four sidebars, and then just click in your drawing if you have 4 bars, and then press escape to escape the command, and then you have the 4 bars as you would like them. We now want to use propagate. And how would we use propagate? Well, we already have the columns everywhere in place, but what we don't have yet are the sidebars. So what we do is we launch propagate with base solids, the 2 columns. Press enter. As detail objects, you want the sidebars, because these are not at our destination locations just yet. And then press enter. Then it's asking me as a block or as a copy. In fact, you can choose, but I will now make a copy, because if you would want to model further, then it's useful to have a copy. And then you will see that it nicely makes the other suggestions at the left-hand side. But at the right-hand side, it detects as first option to be at the same side as the one we were at, but we want it to the outside instead of to the inside, because this becomes the inside at this side. So I want to choose the alternative option, option 2. And I want to do that for every one of the check marks, so that you always have the option of the sidebars at the outer location of your structure, and then press enter to accept. And then you will see that in fact they are at the outer location. So that's good. We now modeled some sidebars where you could now model further cladding onto etc. But for now we will continue with cleaning up some details, because we have now our structure. It could be that you are satisfied with this, but I want to clean up these connections as well. So I will start with the top, because the top is not nicely mitered now. It's just really not attached to each other. It's just straight onto the profile. So I want to launch the L-Connect tool from the Model tab, the L-type connection. So not the structural connect, but the L-type, because I have 2 beams and I want to connect them in an L shape. So the first option is a miter connection, which is good. So I just press enter. And then you see the connection is nicely mitered, and we can propagate this along to all the other destination locations. So launch propagate, and as base solids you now have the beams because they already exist in the destination location, and you press enter. And as detail objects, well, there aren't any details we want to propagate along, so just skip that step because it's optional. Just press enter to don't select anything. Then it's asking me if this is what I want to propagate, this is what I want to propagate, so I choose yes by pressing enter. And then you see it gives me all the check marks. It has a little exclamation mark next to it because there is some interferences if you propagate this detail. That's nothing to worry about because we will fix this in a later step. So just apply them all. And then you see the second one is also nicely mitered, as well as the third one, and so on. Now I want to model this part better. So I select those three entities, and I now will use the structural connect tool. Structural connects two or more elements in a smart way, so that's why I use the structural connect. And then you see it automatically detected that this member should only come to this beam and this column should be nicely to the side of this beam. Then the last thing I want to do for this connection is to L-connect these two again. So instead of structural connect, choose L-type connect again. Then the first option is again a miter connection. I don't really like this in this case, so I press Ctrl once. And then I see it is now to the side of it. This could be a valuable suggestion, but I want this suggestion where the beam is on top of the column. So I press enter and I accept this suggestion. And now again, we can propagate this detail to the other locations. So launch propagate, select the base solids. These are the four profiles. The detail objects, well, there aren't any because the base solids, they are already in place and there is nothing we want to propagate along. So again, just enter this step because you don't want to enter anything. And then it's asking me, is this a detail that I want to propagate? I say yes. And now it will find all the possible suggestions and I press enter to apply them all. So then you see that all the connections are nicely modeled again and propagate did its job. So there are other ways to propagate a detail into your drawing, and that's the details panel. In the details panel you can store details and you can reuse them into other drawings, or you can parameterize a detail so that it adjusts itself to a certain angle or a certain tolerance. So we will now take a look at the details panel. So go to the details panel, and then you will probably have an empty details panel, or if you already did the previous modules of this training, you will have some folders here, but not the ones that we need. So I will show you again how you add a library. So you, first of all, in our training folder, you can go to the starter files, to structural modeling, and there you have a detailed structural zip file. You can unzip this one to details structural because we need the folder unzipped to add it to the libraries. So now you can go to the three stripes at the top of your details panel and go to manage libraries. You will enter the settings dialog, and then if you press on the three dots here, you will enter the pod list. And there you will have probably already the standard part where your custom details are saved when you create them from the panel. Or you will also already have a pod that refers to the other part of the training. But now we want to add the third pod, or second one in my case. So I click add pod and I click on the three dots again. And then I go to my training files, I go to the starter files, to the structural modeling folder, and there I choose the unzip details structural, and I select this folder, and I press OK, and you should immediately see a structural folder show up in your details panel, and if you click it, you should see three connections there. We now want to take a look at the truss connection. So if you just click it once, it will open this preview, and you see at the top that it says parameterized. What does it mean? Well, it means that it can adapt itself to certain tolerances. So for example, the angle can differ 45 degrees from the original modeled detail, so that it still adapts itself to that model, to that found location. The profile dimensions can differ with 200 millimeters, the offsets with approximately 100 millimeter. So you could open a file here, but now we will propagate this file. So just click propagate. And then it will take a while to find all the suggestions because we have a lot of different angles for the truss in our model. And we want to find all these locations for the propagation, because it's a parameterized detail, it will morph itself into the correct position. So this is why it takes a while for Propagate to find all the similar connections. And then it found all the suggestions, and you see that there are a lot of suggestions, so it's normal that Propagate took a while. And we want to apply them all, so we just hit enter. Again, now the morphing will really happen, so it might take a few more seconds, but then it will apply all those details, and we will have a nicely detailed model. So you can see now that it's done with the morphing of the geometry, and it was updating the linear axis. And if I zoom in, you see that now the connections are nicely modeled. Even the plates, they adapt themselves to the profile, because one profile was bigger than the other, and still the plates adapt themselves. So that's pretty convenient that you can use Propagate on a parameterized detail. In the next step, we will make a detail for the details panels ourselves. So what we will do is we will isolate the first column and beam. So go to the selection and isolate the entities, so that you only have this one left. We will create a plate, a bolted plate at the end of the beam. So you can draw a box. While you have launched the box command, you can press shift to lock this face, and now I can start drawing anywhere on this face. I want to start drawing on the end point of the beam, and then you see I'm drawing inside this face. And then I want to end at this end point, at the other corner point of the beam. And I want a distance of 10 millimeter. So a 1 centimeter thick plate. You see now they are still overlapping, but we will fix this in a minute. So if I now select one of the side faces by holding down Control, I can push-pull this face. I want to push-pull it with 20 to each side, and then you see push-pull automatically subtracted the push-pulled object from the other objects it's crossing. So this is a setting called DM push-pull subtract. If you put it on, it will automatically subtract. If you put it off, it won't subtract. And then you need to subtract manually. But in this case, it was convenient that it automatically subtracted. And then we can go to the components panel. And if you have here the Brixis design library, so click on the three lines again and check Brixis design library. And then you should have a folder called standard parts. Open that one up and go to the bolt category. Then go to the hex head category and to the ISO category. And then go to ISO 4D15. If you drag that one into the drawing, you will see that it's attached to your cursor, and it's automatically positions itself in the surface you are working on. So we can position this bolt with the dynamic dimensions. We can give it a distance of 30 from the side and 55 from the top. And then press enter to accept this destination. And you will see now we have a bolt in place. We can now use Propagate to distribute this on an imaginary grid onto the solid face, onto the solid. So I use Propagate to have this solid as a base solid, because that's the location that I want. So I select this as base solid. As a detail object, I select the bolt. Now it's asking me if this is what I want to propagate, so I select yes, and it's giving me a question mark. If I turn it in as check mark, I will see already one suggestion based on a similar location, but I want to base it on a grid, an imaginary grid that it creates onto the base solid. And then you can choose, you have standardly a 2x2 grid, and if you add a row, it will add one row. So this is what we want. So click enter to accept, and as you can see, it turns red because it's interfering, but we won't mind for that just now. So click enter to accept, and you have this nicely bolted plate in place. Then I still want a plate for the beam to rest on during construction phase. So I will extrude this face. So don't use push-pull, but use solid extrude. Then it will create a new solid instead of push-pulling the existing solid. And extrude it with 15 downwards. And now push-pull the front face with 40. So that we have a 50mm plate on which the beam can rest. So imagine that this plate is welded onto this column, and this plate is welded onto this beam, and then it's bolted in place with the bolts. What we have now is just solids and block references, but that's not what we want. So I want to select those two plates and I want to classify them. So go to the BIM tab and choose Classify Manually. Then you will enter this dialog and you can search for plate and you can classify it as a plate. Then you can go to the structure browser and choose the 6 block references. These are the 6 bolts. Again, I can use Classify Manually to classify them as a mechanical fastener. So choose fastener and choose mechanical fastener. And then they will be, you will have 2 extra plates and you will have 6 extra mechanical fasteners. And then I'm not fully satisfied just yet. I want this to become one block. So I classify it as one block. And I will classify this block as a building element. So if I just type in classify manually again, or go to the quad and classify manually, I can search for building element. So I choose building element. And then down here, I check the option convert to block and classify the block reference. And I choose a name, so bolted plate, for example. And I choose OK. And now you will see this has become a block which is called bolted plate. So that's an easy way to convert an entire set of elements into a block that's already classified. So we now have this block and we will create a detail. To do that, go to the details panel and click on the create detail button. Again, it's kind of similar to propagate. It's asking me to select base solids because it will propagate based on these details. So it's asking me to select base solids as well. So I select the beam and the column. It's asking me to select the detail entities. So I select the block reference or the building element. And then I need to give it a name. So bolted plate, for example. And I need to choose a category. So the one that I'm currently in. And I need to select create. Then it's asking me if this is the detail I want to be saved. That's okay for me. You can still adjust the thumbnail that will be shown in the details panel by clicking on this pencil, repositioning your view and clicking enter. You could give in some tags, but we won't cover that now. And then you can click save. And then if you now go back to the structural, you will have a bolted plate. If you now isolate everything, so if you show everything again, you can now drag and drop this bolted plate into place. And then you will see it gives me all the suggestions, and there was a question mark in the beginning that I turned into a check mark because it will then replace it by the detail found in the details library. So press enter to apply them all. And then you should see that the bolted plate is in place. So that's easily how you create a detailed connection, but as you have seen before, it was still interfering with my column and my plate. The bolts were interfering with my column and my plate. So I want to adjust that. For that, I will just undo some steps. So I will undo until the point that I have these loose elements, these loosely classified elements again. And now instead of making a block from it, I want to make a component from it. Why is that? I want to be able to replace the component by another component that's already in your starter files later on. So to do that, I will use the command bmform, but before we use it, we have to make sure that our user coordinate system is oriented correctly, so that if I insert the component, it will be always with its back onto the face that I'm inserting it onto. So I want to set my UCS to this face of the column, so to this one. And I will do that by typing in UCS and selecting F for face, and then selecting the entity. From the left-hand side, you should enter the face and select it like that, so that your Z-axis is pointing away from your surface, your X-axis is pointing kind of towards you, and your Y-axis is pointing upwards. So you can then choose enter to accept. And then I will create a component by selecting everything I want to be in my component. So these are all the bolts and the plates. And then I type in bmform. And I type in L for local, because I want to make a local component out of it. And then I choose an origin point. It's asking me to choose an origin point, and I choose the midpoint of the plate towards the flange. And I give in a name, for example, bolted plate component. And now if I hover over it, you will see that it's a block reference as well, but it's kind of a smart block reference. It's a block reference that's also a mechanical component. If you go to the mechanical browser, which is this one, you will see that it has a bolted plate component now. That's the one we just created. So bmform is actually a mechanical command, but it's also available in BIM, because in BIM we also use components for chairs, for example, or for windows. Because you can then insert them with parameters in your drawing, and it's like a smart block. So you now have created this component, and instead before you had just a block and you didn't have the options of open a copy or replace or dissolve. These are all options that come because we have made a component out of it. So what we now can do is we can replace the source file. But before we do that, we have to set our UCS back to world. So that, again, our X-axis and Z-axis and Y-axis are again in the world coordinate system. And now I can hover over my element and choose replace. And then I can choose from file, and I choose bolted plate.dwg, and I press open. And then you see it placed itself in the same location. This is because our definition plane was the same as the plane in which we modeled in our drawing. But you might not have seen much difference. Why did I change from the one block reference to another? Well, if you open a copy now, you will see why. So you see that it's kind of pinkish here. If I just show my layers, there is a special layer here called the BC subtract layer. This one. If I only show that one, then you will see that there are some just cylinders which represent holes. So the BC subtract layer are solids that represent holes. Once you insert the solid as a component or as part of a component into another element, into another solid, then it will make a hole out of it. So it will be a solid that creates a temporary hole into another object. So you can close this drawing again. You don't need to save it. And then you can see why it's useful that we have replaced this component, because now it will create holes into our column. But as you can see, the column, if you hover over it, there are no holes in it. If you hide the component, there are no holes in our column just yet. So show your component again. And what you now need to do is hover over your component and choose Update Selection. And then it will create features, as it's called. It will create the holes into your column. So if you now hide the entities, you will see that the columns have holes, but these holes are only temporary. If I show everything again, and if I now delete this component, then you will see the column has been restored. So it's a smart hole that's created, and that's what we wanted. If we now turn off the base subtract layer and we would do interfere onto this command, they won't interfere anymore. As opposed to what we had previously, where all the bolts interfered with the columns and the plates, we won't have this problem anymore. So if you launch interfere, you won't find any interfere solids anymore. But you haven't propagated it into your drawing just yet. So what you can do now is to make this a detail as well as like we did the previous time. So again, the base solids are the beam and the column. The detail entity is the plate, so the component this time. So I will say bolted plate component. I will choose the category again and I choose create. It's asking me if this is the correct detail. I choose enter to accept it. You could change your preview and you click save. And then you will have a new bolted plate component in there. If I drag and drop it into my drawing, if you have made everything visible again, you will find again all the options. So check mark all of them and click apply all. And then you will see it's propagated all the way until in our drawing. And the holes are automatically made. If you delete it, again, it's a smart hole. If you hide it, you still see the hole. If you delete it, the holes go away. So it's a smart hole that restores itself once it's not present anymore. So if I would do interfere now, and I I choose everything, and I check against the same set, so just check first set, so press enter, and then it says solids do not interfere. So this is thanks to what we just did with the interference solids. Make sure you have toggled them off here, because otherwise it still sees it as solids, because these solids are still there, but they create holes at the same time. But the solids themselves are still in your drawing. So that's why it's a smart hole. If you delete those solids, the holes will also be deleted. So that's how you avoid interferences like we had before. Then you can save your file, and I have some extra optional steps for you. One of that is the diagonal braces. So choose in your profile panel, choose the L-type Euro again, and the Euro 35.5. And if you just drag it into empty space, I now want to create it from this face, so I shift select this face. I want to quarter turn it so that it's facing towards my the flange towards the flange of my eye profile. I want to have it until here. So I select this midpoint. And I just click enter to accept and escape to exit the command. As you can see now, it's still interfering with my solids. So again, I have to add some eccentricity to it. I choose upwards, choose enter. And now it's on top here. It's a bit sticking out of my structure, so I will just move the grips a bit. So just grab one of the green grips and drag it until it doesn't stick out anymore. You can do that here as well. So just grab the grips until they don't stick out anymore. And then we will use propagate again. What else? So go to the Home tab, choose propagate on the top beams. Choose the detail object, the brace, the diagonal brace. And then it's asking me as a copy or as a block. Again, I will want it as a copy. And then it will take some time to find the suggestions. You can toggle all the question marks on. So you can click on them individually or make a selection mark or over it, so that you have all the suggestions, and then we can make a pattern like the one that I will now create, because we want it to be to resist wind forces. So we want kind of a weaved pattern, an up-down, left-right pattern, so that we have crosses instead of just diagonals. So, and then press enter to apply them all. And you will see that now the braces are created, so our structure can already resist wind forces. Then yet another optional step is to add some columns in the front portal. How will I do that? You can create a new column. So go to the HEA category again and choose the one we had for the column, but just rotate it the other way around now, so that it's rotated with its flange along the A axis instead of along the 1 axis. And then you need to given a dimension of 4,480, so that it just fits under our structure. Now what I want to show you is how you can easily copy this solid along with display sides and ends on. So you display sides and ends, you put it on. You can also put it on here in the Home tab. And then if you hover near a side of the column, then it will show you the side of the column, and you can BIM copy the entire beam, the entire column at once. So go to the Model tab and choose BIM copy, and then you will see it will copy the column. You're given a dimension of 5,000 because our grid cells were 5,000 apart, and again for the next one 5,000. And you then have 3 columns, and we want them in the back as well. So turn on face detection as well, because you want to kind of have the face side of the column. So you turn on face detection and display sides and ends, and you can select multiple ones as well, and choose BIM copy to copy them all at once. So you have selected those 3 and they display in pink. And if you choose BIM copy, you will see that they are attached to your cursor. And now I want 35,000 because that was the length of our grid. And then just press escape, and you can see that now in the back there are also columns. So you could now mount a cladding on top of these sides of the beam. To conclude, I will make some cross beams on top of our roof structure so that you can mount a roof structure on top. How will I do that? I will again choose a profile. This time you want to put out display sides and ends and face detection, and you want to select an IPN 80, and you want to drag it onto empty space in your canvas. And you want to start from this point, and then you want to model all the way to the end. So you could model all the way to the end, or you could type in a dimension of 35,100, but I will just model it like it is. And then press enter to escape the command. And as you can see now, it's not in the correct, it's again crossing our other beams. So go to the structural tab and add eccentricity. And then choose the up right arrow so that it looks like this, so that it's on top of our top beams, and press enter to accept. So now we already have one cross beam, but we want to have multiple. So what should I do? I will create a rectangular array. But a rectangular array will always be made in the current user coordinate system. So we have to change our user coordinate system to the top of this beam as well. So type in UCS and choose the top face, and then choose enter to accept. And then you should see the x-axis along the slope of the top beam. And that's how you can create a rectangular array in this phase. So go to the model, go to the draw tab in your node selection quad and choose rectangular array, and choose the cross beam to array it. And then you see that it will go into this phase that we just selected the UCS from. And you want to adjust the amount of columns, so type in column. And you want 10 cross beams. So these are 10 columns of the array. And then you want to specify the overall total distance among which the 10 beams should be distributed. So I type in T for total, and I start from this point of the first cross beam to the middle of our construction, so the end point of the top beam. And then you see it's evenly distributed among our half of the structure. And then press enter to exit. And if you now see, you will have 3 rows. We can still adjust that in the properties panel. So go to rows and put it onto 1. In here in the miscellaneous, you can put it onto 1. And then you see you only have one array left. And now we want to mirror this, but we want to mirror it in the world coordinate system. So type in UCS and put your coordinate system back to world by pressing enter and accepting world. And now type in the mirror command. And then select the entities to mirror. That's of course our cross beams. And then the start of the mirror line is one of the middle grid axis intersections, and the end of the mirror line is also the next intersection point. So that's the middle of our structure. You can easily find based on the grid. And then you want to keep entities, so type in N for no, or just press enter if that's already the suggested approach. And then you will have this nice steel structure with cross beams on top. And that's where we conclude our demo, and I will just show you in all its glory our steel structural hull. So you can view it from different angles. So that's really all your effort has been put into this, and you can still model it further to make, for example, cladding on top of it, or just let your imagination loose, and that's about it. So I hope you enjoyed this training lesson module, and see you in the next module.